Hi guys, today I'm gonna show you the configuration of a router that performs routing between VLANs. This concept is commonly known as router on a stick or one-armed router. A router on a stick is a term frequently used to describe a setup that consists of a router and switch connected using one Ethernet link configured as an 802.1q trunk link. So the difference between the trunk link and the access links is the access links only allowed to carry a single VLAN traffic, but here the trunk links is allowed to carry forward multiple VLANs traffic. So as you can see on my screen, I have two topology designed, one for Juniper, the other one is Cisco. So let's get started with the Cisco first, and then I will move back to the Juniper configuration. Switch. So here my plan is to create two VLANs, VLAN 10 and VLAN 20, and then I'm going to assign G0/1 and G0/2 to VLAN 10 and G0/3 and G0/Z1/0 to VLAN 20. Let's check the current status of the VLAN. Show VLAN. So by default, all the switch ports belongs to default VLAN. So you can see VLAN, this is the VLAN number or VLAN ID. VLAN ID is 1. All the ports belongs to default VLAN. Config T VLAN 10 name IT interface range G0/1 to 2 switch port mode access switch port access VLAN 10 and then VLAN 20 name admin interface range G0/3 comma G1/0 switch port mode access switch port access VLAN 20. Let's check it. Do show VLAN. So as you can see, I have created two VLANs now, VLAN 10 and 20, but some reason I cannot see the VLAN IT. Instead of I can see VLAN 0010 and the VLAN ID. Let's double check. So VLAN 10 name ID. Do show VLAN. Let's check now. VLAN 10 name ID. To show VLAN. Yep. So what we can see here, VLAN 10 and 20 has been given name IT and admin, and the switch ports G0/1 and 2 has been assigned to VLAN 10, and G0/3 and 1/0 has been assigned to VLAN 20. So the access layer VLAN creation and assigning ports to the VLAN has been done. So now I have to create this link as a trunk link. How to do that? Interface G0/0 encapsulation. So switch port encapsulation, switch port trunk encapsulation DOT1Q and switch port mode trunk. So let's check. Do show interface trunk. Yeah, so G0/1 has been created as a trunk link, and VLAN 1, 10 and 20 are already been in and out to this trunk link by default. So this is it. I have done almost all the configuration with the switch. Now I'm going to move to the Cisco router. So let's check, save the configuration. Copy, run start. This is it. So let's go to the router. It might take a couple of seconds. Yeah. So let's go to the enable mode. Config T. Do show IP interface brief. Currently I have 4 interfaces, but nothing was assigned to those interface. So interface G0/0, which is this interface, no shit. So what is my plan here? I have a single physical interface. I'm gonna keep this interface up, and on this interface I'm gonna create 2 sub interfaces. And how to do that? Interface G0/0.10. This is my VLAN ID 10. Encapsulation dot 1Q VLAN ID 10. IP address, I'm gonna assign IP address to this sub interface or the logical or virtual interface. IP address 192.168.10.1 255.255.255.0. No shut. Let's do the same thing to creating VLAN, to creating sub interfaces, another sub interfaces. So this time it should be 20. And again the encapsulation.1Q and the VLAN ID should be 20, and I'm going to assign the IP address to interface G0/0.20. This time it will be, instead of 10 it should be 20. Now shut. Let's check the status of these interfaces. Do show interface brief. Do show IP in brief. So now you can see G0/0, the physical interface is up, and I have created 2 sub interfaces on G0/0. My first sub interface is G0/0.10, which has been tagged with IP address 192.168.10.1, and the second sub interface is G0/0.20, and IP address 192.168.20.1 has been already assigned for this interface. So that means I have almost done with the router as well. Let's save the configuration. Copy, run, start. So let's check the connectivity. So here I'm gonna go to the PC 8, okay, and assign an IP address from 192.168.10.20 range. Sorry, my bad. I'm gonna assign IP address from this subnetwork 192.168 or 192.168.10.0/24. IP 192.168.10. I have already assigned the first valid IP address from this range, as you can see, 192.168.10.1/24. So I'm gonna assign the second available IP address from this range to the PC /24, and my default gateway would be 192.168.10.1, 192.168.10.1. Now I'm gonna check the connectivity. Ping 1, I'm gonna ping my default gateway 192.168.10.1. Yep. So the ping is successful. That means there is logical connectivity has been established between this PC number 8 to my default gateway. I'm gonna do the same thing to PC number 9. PC number 9. So here IP 192.168.10.3/24, and my default gateway is same 192.168.1.1. So it should be 10.1. Let's ping the default gateway. Ping 192.168.10.1. So I'm pinging the default gateway from VPC9. So the connectivity is fine. Let's move on to the VLAN 20. So here I'm going to assign IP 192.168.20.2 for this PC, IP 192.168.20.2/24, and my default gateway would be this 192.168.20.1, 192.168.20.1. And I'm going to ping the default gateway. So ping 192.168.20.1. Yeah, ping is successful. So that means this PC can see the default gateway. And now let's jump onto the PC number 11 and do the same thing. IP 192.168.20.3/24, and my default gateway is 192.168.20.1. Let's ping the default gateway. Ping 192.168.20.1. Yeah, ping is successful. That means these two PCs, this two PC easily see the default gateway, which is 192.168.10.1, and here the other two PC in VLAN 20 is able to see the default gateway 192.168.20.1. So let's check so in this topology, this the VLAN 20 should be able to see VLAN 10. So how the traffic goes, when I generate the traffic or send the pinging traffic, it goes this all the way to the router and then gets routed through the router to the other VLAN. So now as you know, I'm in VPC 11. I'm gonna ping this the other default gateway 10.1. Ping 192.168.10.1. So that means inter-VLAN connectivity has been established. This VLAN 10 can see now VLAN 10 on the default gateway of VLAN 10. So now I'm gonna ping from VPC 11 to VPC 8 or VPC 9. So ping 192.168.10.2. So that means the inter-VLAN connectivity has been established between VPC 11 to VPC 8. The traffic has been moved from this device to switch and all the way to router to get routed to VPC 8. So let me show this one on a packet tracer design, how the traffic flows through. Yeah, I have a design on packet tracer. So let's ping from this device to the other device, and I'm gonna do it on the simulation environment. Ping 192.168.10. Let's say 2. So this is how the packet starts traveling. And it will get routed to this device. Yeah. So this is how the packets normally in the real world travels. So basically on this topology, and this is it. I have set up 2 VLANs and assigned the interfaces G0/1 and 2 to the VLAN 10 and G0/3 and G1/0 to VLAN 20. Finally make this link as a trunk link, and in the router I have created 2 sub interfaces on a single physical interface. Our single physical interface is G0/0 and this is our sub interfaces. And on these sub interfaces G0/0.10 I've assigned IP address 192.168.10.1/24 and G0/0.20 I've assigned the IP address 192.168.20.1/24. And finally I pinged from this device to this device. Ping was successful. The traffic went all the way to the router to get routed to PC8. This is it. So now I'm gonna move to the Juniper device, but I need a small break. Hi guys, let's get started with the Juniper configuration. As you can see in my Juniper topology, I have a Juniper switch which is VQFX, and I have a Juniper firewall which is a VSRX next generation firewall, but I'm going to use this firewall as my router here. Now let's start with the Juniper switch first. Here let me check whether we have any existing VLANs onto the switch. Show VLANs. By default I can see there is only one VLANs onto the switch, but now I'm gonna start creating VLAN 10 and 20, and then I will assign the interfaces to the VLAN. Configure set VLANs IT VLAN ID is 10, and then I'm gonna create VLAN 20 with the VLAN ID admin. Commit. Show VLANs. So now here we can see the 2 VLANs been created with the VLAN ID in the VLAN name. So VLAN ID 10 has the name of IT and 20 has the name of admin. Now I'm gonna start assigning the interfaces to the VLAN. So here I have 4 interfaces, switch ports you could say. So I'm gonna assign XC-0/0/1 onto VLAN 10 and also XC-0/0/2 as well, and then rest of the switch port like XC-0/0/3 and 4 to the VLAN 20. Set interfaces XC-0/0/1 unit 0 family Ethernet switching interface mode access VLAN member IT. So that means I've assigned the interface x/0/0/1 onto the VLAN 10. Now I'm going to assign interface 0/0/2 to the VLAN IT as well. Commit. Show VLANs. Here you can see x/0/0/1 and 2 has already been assigned to the VLAN IT. Now I'm going to assign 3 and 4 to the VLAN 20. Set interfaces x/0/0/3 unit 0 family Ethernet switching interface mode access VLAN member admin. So I've done for 3. Now I'm going to do for the interface or switch port 4. Commit. Let's see the difference. So run show VLANs. Here we can see switch port XC the 0/0/3 and 4 has already been assigned to the admin. So now I'm going to create this switch port or the link as a trunk link. And how to do that? Set interface XC the 0/0/0 unit 0 family Ethernet switching interface mode. This time it should be trunk VLAN member. So here I need to explain what the difference between trunk and access link. So normally the access link carries a single VLAN's traffic, but when we want to push a multiple VLAN's traffic through a single link, we have to create that link as a trunk. We have two trunking protocol, namely ISL and IEEE 802.1q. So here we are using IEEE 802.1q. So now net switching VLAN members should all commit. Now let me check the status of this interface. Run show configuration interface XC-0/0. Here you can see interface XC-0/0/0, which is now our trunk link, and all the VLANs, namely VLAN 10 and 20, and also the default VLAN 1 already, assigned through this trunk link. That means if you add any VLANs in future to this switch, all will be allowed to go through this trunk link. So this is it. I have done the configuration with the switch. Now I'm gonna jump onto the VSRX next generation firewall. As I said, I'm gonna use this firewall as my router here. Let me save this configuration. Commit and quit. Done. Let's go to the next generation firewall. First of all, I need to check the interface status. Show interface errors invalid interface. Okay, so I have to add run show interface errors. Here at the top I can see my GE-0/0/0, which is a gig interface. though it's a physical interface, but now I'm going to create two sub-interface on the one single physical interface. So to do that, set interface XC, not XC, GE -0/0/0 VLAN tagging unit 10. So that means I'm going to assign, or I'm going to start creating the sub interfaces now. Unit 10 VLAN ID 10. Now I'm going to assign an IP address to this sub interface. How to do that is unit 10 family inet address 192.168.10.1/24, which is this IP address. And then I'm gonna start assigning another IP address to this sub interface GE-0/0/0.20. Here it would be 20 and VLAN ID 20. The IP address would be 20 here, and here should be 20. Commit. Let's check the difference between the earlier status of these interfaces and the status as of we change the configurations. Run show interface first. Okay, so here earlier, if you look at the status of this interface earlier, I can see GE-0/0/0 has nothing been assigned. But if you look at this G here, GE-0/0/0, here you can see I've created two sub interfaces, and the IP address of sub interface GE-0/0/010 is 192.168.10.1/24, and the other IP address from different subnet range is been assigned for the sub interface .20. Show configuration interface display set. So here you can see all the configurations have been added to the SRX next generation firewall. This is my configuration. Now let's assign an IP address to this PC and ping from this firewall or the router. VPC, so let's check show. There's no IP address been assigned to this PC, so now I'm going to assign an IP address from this network. So the first valid IP address from this network has been assigned to the sub interface GE-0/0/0.10. Now I'm going to assign the second valid IP address from this network to this PC. So IP 192.168.10.2/24, and my default gate would be 192.168.10.1, 192.168.10.1. Let's go to the SRX next generation firewall, and I'm going to ping the PC 10.2. Ping 192.168.10.2. 10.2. Ping gonna be fail. The reason the ping is not successful here, as I told you earlier, that I have used a next generation Juniper firewall here instead of a router, but my intention was to use this firewall as a router. As you know, by default, the firewall is denying all the traffic. As such, it's denying our ping traffic as well. So what I'm going to do here, I'm going to allow ping for interface GE-0/0/0.10 and 20. And how to do that? Set interfaces, set security zones, security zone again, trust interface GE-0/0/0.10. So now I'm assigning the I'm allowing the ping for subinterface GE-0/0/0.10 host inbound traffic, system services, and the services I'm going to allow here is ping, internet control message protocol echo request, ping. I'm going to do the same command for subinterface 20. Now let's check the difference. Ping, ping 192.168.10.2. So the ping is successful. So the router is able to ping the VPC 10.2, which is in under VLAN 10. Let's try the other PC, which is VPC 510.3. Ping is successful here as well. Let's try PC on VLAN 20, VPC 20.2. Ping is successful. Let's try ping into VPC 13, which is under VLAN 23. Yeah, so the ping is successful. That means I have established the inter-VLAN connectivity through the router. So the router is here switching the traffic from VLAN 20 to VLAN 10. And this was it. So configuration has been done successfully. One of the biggest advantage of creating sub-interfaces on a physical interface is in the enterprise world, people might have hundreds of VLANs traffic that need to be pushed to the upstream router. Technically, each VLAN in the switch needs a separate link to transmit the traffic to the router. On the other hand, the router also needs hundreds of physical interfaces to receive hundreds of VLAN traffic, which is almost impossible. This sub-interface concept saves our huge amount of money and makes life more easier and flexible. However, if you like my video, please subscribe it, and I hope I will see you on another video. Stay home and be safe.